being said,
I would have just pushed it.
Hello, Bill. That's Chester calling. I was thinking about coming by about 11 a.m. Would that be all right? Hey, Ruth. Doing fine, doing fine. I'm at a workshop this morning. I thought I might come by afterwards around 11. Okay? Okay, great. Would you like me to call when I'm on the way, or you leave, Wonderful. Yeah, I'll certainly be there within that time. No problem. All right, thank you, Ruth. I'll talk to
Maryland, and we're happy to host the 3D Printing Innovators Meetup today. 3D Maryland is a statewide leadership initiative to raise awareness of 3D printing and additive manufacturing and the competitive advantages, as well as to facilitate engagement and implementation of these technologies among business, industry, and entrepreneurs. We want to build Maryland into a hub for 3D printing and additive manufacturing, driving innovative economic development for the state of Maryland. And Maryland's uniquely poised to do this. We have a lot of very unique and tremendous assets. 3D Maryland is an initiative of Howard County Executive Ken Allman and the Howard County Economic Development Authority in partnership with the Regional Manufacturing Institute of Maryland. And we're located in the Maryland Center for Entrepreneurship. And I know that's kind of a mouthful. We have a lot of partners, and we like it that way. We really think that when we link arms and we work together across the ecosystem, that's our best chance for moving Maryland forward. And that's what's at the heart of 3D Maryland and what we're about. We are tech savvy, so our Twitter handle is 3DInMD. So if you're a tweeter, please tweet us today. At future events, if you have a Twitter, if you're presenting and you have a Twitter handle, give that to us ahead of time, and we'll put it on the information, and you can be part of our tweeting circle. So 3D Maryland is a hub for 3D printing and additive manufacturing in Maryland. We're building a loosely coupled system of collaborative relationships across sectors and across industries. We hope today's event will further those connections and connectivity. 3D Maryland's been very busy since its inception, so I hope you'll check out our website. I'm not going to go through everything that we've been doing, but it's on our website, www.3dmaryland.org. And today we're kicking off the 3D Printing Innovators Meetup as a way of connecting the broader ecosystem. So we've been really busy. We've had a lot of pieces in play, a lot of really great things happening. But there's more that there's always more that we can do, and bringing the broader ecosystem together is definitely one that's been high on our list, and you guys have been knocking on our door. So here we are. So this group is for to connect the broad ecosystem from people that are using the technology, people that want to know more about the technology, place to ask general questions, people that are researching and developing the technology. So we have a number of printers that are being designed and manufactured in Maryland. I think that's phenomenal, and we want to make sure that people know about that. But it's also the place for people who are brand new and want to know more, whether you're an investor or you're a pure novice. You're like, I just want to know about this for, you know, my grandkids or my kids or whatever that is. So this is a place for everyone. So please pass the word. We're going to try to do these monthly. We are not going to meet in July, but we're going to try to meet again in August. So we are going to either be monthly or bi-monthly. So we're really glad to see you all here. Thank you for being here. And so we're really trying to grow the rapid tech ecosystem in Maryland. And to that extent, I want to thank Trimex Solutions, Steve Simonetti and Jeff Wicklin. Steve will raise his hand for sponsoring today's event. Trimex Solutions is the go-to company for engineering results. They have 6 offices up and down the East Coast. They partner with engineering and manufacturing companies to enable innovation and to support the improvement of product quality and facilitate the reduction of time to market by providing a premier blend of people and technology. So there's at least 3 different sectors of Trimex Solutions, and they bring a lot of the important parts together to provide great support and solutions. Trimex Solutions is a longtime partner of Stratasys, and many of you will know that Stratasys is one of the hardware manufacturers for 3D printing. So the format today, we have 3D Maryland has a user survey on our website. And one of the highest ranked things that the user group and the community wants in terms of 3D printing is networking. So we started with a half an hour of networking, and we'll conclude with a half an hour of networking. We have 4 7-minute presentations for you today. After each presentation will be 5 minutes of Q&A, so you can get ready for that. In the middle, what I'm calling halftime, we'll do some shout outs. We'll give our sponsors some time at the microphone. We'll tell you about some of the things that are coming up. So that's our plan for today. Sound good? You excited? Everyone caffeinated? It's going to be awesome. Okay, first up is Chad Schneider. Chad is a mechanical engineer, a mechanical designer experienced in the process of product development. He enjoys designing practical, efficient, and robust electromechanical systems and offers extensive knowledge of various rapid prototyping and manufacturing techniques. In 2012, he founded Route 3 Labs, a product development company specializing in design, prototyping, and commercialization of complex devices for the medical, industrial, and consumer electronics industry. Please welcome Chad Schneider.
Thanks for having me. Again, my name is Chad Schneider, and Route 3 Labs does device prototyping and product development, so I have a couple of projects that I can talk about and how we use 3D printing, both for in the stages of product development as well as the finished product. So this first project is I use 3D printing for design evaluation, which means I started with the problem. The problem was this device here is for a senior living facility. It's for a chair, and that's sort of the finished product. This is the original one with the metal bracket. You step on this, it lowers these wheels here, raising it up on wheels, and you can slide someone in and out of their chair, or in and out from the table, say a dining table. Helps the orderlies, they don't have to sort of shimmy someone in, and people like it because it's a little more graceful, and you're in front of your friends, things like that. So what they wanted to do was they wanted to decrease the cost to go to injection molding, and they wanted to improve the appearance of it. So, so I helped them do both. So first I started out with a concept and showed them, here's all the forces involved, and did the engineering on it, and how we would put this all together. But I really wanted to evaluate whether my calculations were correct. There was definitely some assumptions made, and then also be able to show them that it would work under the capacity that they were looking for. They want to be able to lift somebody up to 350 pounds, and also have it be something that anyone could, even a child could press down with maybe 40 pounds and be able to do. So that's one of the advantages of the design. It's got a lot of mechanical advantage, the lever action. So I built FDM parts, and so I took the design that I made and I designed it for FDM. And by that I mean I made it so that it could be 3D printed. FDM is fused deposition modeling. It's a type of 3D printing. And I had features in there that would not work. So I knew that this pin that's in the joint here, this joint, there's a lot of shear load on that pin. And that's really what connects the back to the front. And that shear load in a 3D printed part that has layers that go up, that shear load would just kill it in no time it's flat. So this shows you the layers as they were built on that pin. So what I did was I designed that for a 1/2 inch piece of Delrin rod, And so I could substitute it with a cast part that's very strong and would hold the shear while I evaluated the rest of the components. There's no point in evaluating that pin as it is right now. So I did that, and I was able to test it. I built this fixture to sort of replicate a chair, and I could load it with up to 260 pounds. So I really wanted to get to 350 pounds. And I was surprised, but these 3D printed parts made it up to 260 pounds. So over 60% of the rated load capacity in a 3D printed part. So I was feeling pretty comfortable that the design was going to make it. I also learned what some of the weak spots were in the design by where these parts broke. And so based on my experience with 3D printed parts, I kind of knew where I expected the 3D printing to fail and where the design was actually causing problems. So I was able to identify some parts, tweak the design, learn about how these parts were fitting together, and go into the next phase. So then I redesigned the actual models for CNC machining. Now I can 3D print these in an ABS material, but it's not the same as if you machined it in an ABS material. You're going to get a lot of these 3D printed layering. You know, it's a very non-homogeneous material, so the layers are strong in one way and they're not strong in another. So I wanted to machine those parts. So I designed everything to be machined. That means I added things like radii on these that you could put a machining bit in, and I took away kind of draft, and I machined all the parts out of an ABS material. And then I was able to test it and get up to the 350 pounds over 100 repetitions, which wasn't perfect, but when they broke, I was able to identify what the weaknesses were. So then the next phase is to redesign it for a completely different process, which is injection molding. So I want to redesign all these features for injection molding. These fillets here, all this material, it's really bad for injection molding. You're going to get sink marks. These ribs are really large, and for something like machining, I'm taking material away, so I don't care how big those ribs are, but I want it to be sort of replicating the design. At the same time, I don't care about having these big materials, but the ribs, I can do sharp edges on a rib in an injection molded part. I want to have some radii, but really small. And I'm worried about how thick those ribs are, because on the other side, I'm going to see sink marks. So I redesigned it completely, not completely, but I added draft and filleting and features like that. So you can see on the top there's ribs where there weren't any before. And so I redesigned it for injection molding. Other features are things like there's a little grip here for your foot that, you know, it's not worth trying to get someone to machine that feature in, like a knurl. But the advantage was I was able to get those parts injection molded, and now they're in the real material, they're injection molded, and I can do 350 pounds, 5,000 repetitions, which is well over the life that's expected. And so now they're in injection molding, and these are the first articles out of the injection mold. So I do inspection, and I evaluate and show that they're within tolerances. I have some prototypes of this you can take a look at later. And they go from the original through 3D printing, CNC, and injection molding. The other thing I wanted to talk about was how I used 3D printing for actual finished prototypes. So this is a project where the bead connects to your phone and it vibrates, and the application is that you can move it from part to part. So instead of having just a watch, you could put it on a piece of jewelry, you could put it on a necklace, any kind of a brooch or a hair clip or something like that. So these are SLA parts that Repliform coated with a nickel plating to make it look like actual jewelry. And so, you know, to help my client demonstrate their product really well at a low cost. And I think it looks pretty good as you can get for jewelry without doing the actual casting. Another part is it's a 3D printed earbud organizer. So the earbuds, you pull them out, they lock, then you push them and close, and you can have this organized, and you don't get the tangle of wires in your pocket or your briefcase or your bag or whatever. And so this is a prototype that they're showing for, you know, kind of licensing deals and things like that. So this is a finished prototype. It's been, you know, finished and polished, but it's just a 3D printed part. So I think I'm out of time, and that's it for me. So, Sean?
When you injection molded them, did you use a fiber reinforced ABS plastic or did you just use neat resin?
This is a glass-filled nylon. It's 13%. So I went with ABS through the whole thing, and calculations showed that should have worked, and it probably would, but the glass-filled nylon was only a small price difference for a huge amount of stiffness, and so it helped some warping issues. Yes, sir?
Now, how did you make the mold for the injection molding? Was it machined or was it 3D printed? The mold itself?
The mold for the injection molding?
Yeah.
No, it's a high-strength steel.
You cut
mold.
steel?
Yeah.
Okay.
I didn't cut the steel. I paid a mold maker to make the mold.
Other questions?
Yes, sir?
How would you say 3D printing helps you compared to other processes you would have used in the past?
Well, the 3D printed part cost me maybe under $1,000, $700 to $1,000 for 2 models of them. One I could send to my client, one I could keep for testing. The CNC parts were more like $7,000 to get those made and built and tested, and so it's worth it, but it's expensive. And so I could make 3 or 4 iterations of the design with a 3D printed part that just would not be feasible in a CNC part. And injection molding, the tooling, you know, tens of thousands of dollars. So you wouldn't really want to iterate those.
Rose?
I was going to ask what software you're using on the modeling?
SolidWorks?
Other questions?
Did they come with you? Did they come with a design to you, or did you kind of take their idea and then fully design it?
They came to me with the metal part, and then I had to create everything, the shape and how the parts fit together. There's a host of criteria, including that they had to fit different chairs. It's an aftermarket part, so it fits different size chairs. And so the ability that's why there's a joint in the middle, so you can shift, for any width chair. And so, yeah, I did all the design work and then all the fabrication.
Can you let us know if you had looked at any other 3D printed material prior to choosing FDM as your choice for going forward?
Well, I mean, I'm very experienced with different materials. FDM has a high strength. You're getting ABS material as opposed to an SLA, which is a lot more brittle, or something like a Z-Core powder. So ABS is definitely, the FDM has a very good value for strength. I mean, SLS, maybe I could get a nylon or something, even or metal, but it just would be very expensive.
Sure. Thank you.
How did you source the injection molder?
Well, there's a molder in Forest Hills, Maryland, called Federal Tool, Old Federal Tool, and they took care of they do the injection molding and they take care of how the mold is made. The advantage being that they work out all the details of when the part doesn't come back, they handle the molding and how parts are tweaked. And these parts are defect. The mold, they're very early stage, so there is some warping on them, which is why I got to keep them. So.
It's a 2-point question. One is, what was the distance between your collaborative design and your end user client or study group that was evaluating the product? And 2, in your background and history of designing parts, how much time and energy was saved with your ability to create and model in 3D as opposed to electronically transferring a CAD drawing for review and then sending out the prototype for other sort?
So to answer your first question, my client had been selling this in the UK for several years, so I took their input as customer input. I didn't have access to the actual customers who would be using it, which, ideally I would get that feedback and I would be able to work with them, but they were very knowledgeable on their product and their market. They'd done a lot of research and understood what was needed and what they wanted. And your second question of using 3D modeling to design as opposed to, say, 2D AutoCAD, I guess. I mean, yes, the parts that came out from the 3D software they built and they were put together. Everything worked well, and so with 3D modeling, I'm able to check tolerances and visualize things very easily. So I have worked with 2D software, but it's been so long, I would definitely not go back to it.
All right, Sean, last question.
What was the cost of this versus the cost of the metal one when you were all done?
I can't really say that, but it's better.
Can you give like a bracket of savings?
I think it's easily a 30% savings in cost, maybe even more. And the advantage of it was assembly. So they're able to just package it and send it out the door. The metal one always required a little bit of tweaking to get on any kind of different size because it doesn't have that hinge. So you would be expected to step on it and pull it until it fits. So that's advantages over that. So.
All right, thanks, Chad. You can ask Chad more questions later. I think, and you can also obviously check this out with other folks that are in the room, but I think that 30% savings is right down the middle. A lot of times it's more, but it's usually 30%. All right, next up is Evan Roche. Evan is a recent graduate of the Maryland Institute College of Art, where he and 2 colleagues designed and built a Jimmy Beta 3D printer. He's going to tell you about that printer, and tomorrow, as part of the Nationwide Day of Making, sponsored by the White House, you can either stop by 3D Maryland's Innovation and Prototyping Lab at the Maryland Center for Entrepreneurship, or check out our webcam and watch Evan build a Jimmy 3D printer in our lab. So, and soon we're going to offer Jimmy Beta, right? Jimmy Beta, yeah. 3D printing build classes. So please welcome Evan Roche.
What time is the drop-in or whatever at the lab?
I think Evan's going to be there around 9 o'clock to get started, and I think it's going to take at least 4 hours to do that. So I decided that we were going to invite you all to be there last night at about 10 o'clock. So stop by, we'll host you. My team loves me, I swear. You can also check out our webcam. It'll be hooked up to our website, so you can see where he is in the process. If you live close by, you can jet over when it looks exciting. How's that?
Or save the carbon and just watch on the webcam.
I'm green.
All right, hi everyone. So over the past 6 months, I've been developing the Jimmy Beta 3D printer. So I've been working on this with 2 of my colleagues, Harrison Tyler and Lucas Harrelson. So the printer is designed to be a flexible platform for FDM printing in various materials. So one of our biggest inspirations working on this project has been working in Micah's Digital Fabrication Lab. So that's the Maryland Institute College of Art. So while we're there, we really have the chance to work using the machines in this hands-on and experimental way on a daily basis. For example, not only are we operating the machines, but also fixing them when they break and then altering them to fit our needs at a given time. So that really lays the groundwork for us to decide to develop our own machine. And this is the tool that we really want to use as sculptors. We all graduated from Micah as interdisciplinary sculpture majors this previous May. So this is the Jimmy. As I said before, it's a flexible platform for FDM printing. And we've designed it to be hooked up primarily for syringe printing. So we put paste materials in a syringe, just an ordinary syringe, and use an air compressor and an air regulator, and that pushes the material through. So considering paste such as ceramics or foods or gels, I've made some paintings on it for a little while. Some detail shots. And one of our goals with the design was to make material changes as straightforward as possible. So you can switch out between the plastic hot end or the syringe, different syringe adapters, just on a simple mounting bracket on the X carriage of the machine. And you can see on this machine it's actually hooked up with a plastic extruder right now, which is the normal 3D printing PLA. So this is an example of printing in liquid nails. Just one of the pastes that you can put through. There's some tested PLA, more liquid nails. And one of our goals with this project is to keep it open source. We see this as an expansive platform, and people who are using the machine will come to it with their own skills and also their own interests. So perhaps a chef might come to it with skills and interests that we would not have ourselves. So we would like to be there to provide them with this platform to use as a natural building ground, but then also facilitate the community that builds around this printer. And that community is really important to us. So one way we've been starting to build this community is through these build classes. It's like Jan was talking about. We hosted our first build class this June, and that was hosted at MICA. So about 9 people came in, and together we worked with them to construct a Jimmy for each one of those people, and then also teach people about 3D printing, or if they knew already, to advance their knowledge of maybe how the tweaking of the software and the firmware might work. So here's some pictures from that class. And that's Harrison right there. And Lucas on the right. My other 2 team members. So that class was a big success. All of the printers went home working. Which is actually kind of rare for build classes. So we set everyone up with just printing with plastic for this first round, just as a trial run to see how these workshops would work. So in the future, we're hoping to get this pneumatics kit down to about $200 over the usual build of materials cost, which runs at about $700 right now. And then also building the community, we're really planning on considering the online component of all of this. So right now we're constantly adding content to our website, jimmyresearch.com. So you can go there, and it's going to be this really comprehensive resource for anyone who's building and owning one of our printers, or also building and owning a printer in general. And then also, this would be the platform that we would use to start sharing the material settings, such as different air pressures that could be used with the syringes to push materials through at different rates. So yeah, we're really excited about moving forward with the next build classes and continuing to update the machine. So thanks very much.
Questions?
You said how much do you charge for the class and for getting the machine? You said the machine is what, about $700 in parts and so forth?
Yeah, so for the first class, we were able to offer it just at material cost, just as the trial run. Mm-hmm. In the future, we'll be maybe making some changes to the build of materials, getting some more expensive electronics that will be more effective in the long run. So we'll update those, update the material cost, and then also start to make it sustainable for ourselves, but making some profit as well.
Okay.
Work in progress. So I grabbed Evan right at the end of the first build class. His professor, Ryan Hoover, who runs the digital fabrication lab at MICA, called me one day, one afternoon, and he said, "Jan, we're having a build class. Can you stop by before the expert user group?" And I was like, "No, yes, I'll be there." And I walked in. You can probably hear me. Can you hear me without it? So I walked in, and I was just like, my phone was full. I couldn't take any photographs, but I wanted to get Evan in. So it's been quite a ride in the last week for Evan.
Yeah,
we're going from finishing the build class to being on our roster, being in our lab tomorrow. And we're like, let's run these classes for everybody. So work in progress, but it's awesome. Other questions, Sean?
What's your target audience for your printer?
Yeah, so I mean, right now we're just working with individuals in Baltimore's community, but I think in the long run we're really interested in this being a platform for labs and institutions to maybe own and then share between groups of people. As we develop a printer, I think it would be great to for it to fit in a spot in between the lower end open source rep machines, and then maybe the more expensive proprietary machines that give those really consistent results. So if we could fit in a spot between the accessibility and customizability of the lower end machines, but still have that consistent results that we're given, that would be a great spot for us. So I think that would be a community who would be knowledgeable about making changes to a more complex machine.
Are artists one of your targets?
Definitely, yeah. You know, ceramicists, and then wherever that leads from there.
So you basically are going to have a broader range of materials that might be possible.
Yeah.
With things.
And that's why we want to get people using the machine as quickly as possible, because we can only test so many at a time.
So you mentioned upgrading the electronics to have a more reliable, repeatable process.
Yeah.
So today it's $700. What do you think it's going to be after you upgrade it?
That upgrade alone will only be about $50 per build. So that's just upgrading from our Rams board, which is a pretty common board for 3D printer controlling, to our Rambo board. So we've been working a bit, talking with the developer of that board. That will give us, it has more outputs that we can use for the air controller, is the main interest for using that board. $50 per build in addition. Yeah.
You mentioned liquid nails.
Yeah.
I'm an old carpenter from way back, and my experience with liquid nails is it's a sticky mess. So, how does was it a test material, or is it an actual build material?
Definitely a test material.
Okay.
Yeah.
So I'm going to say, when it comes out, how does it keep its form? Because it's going to want to droop and sag.
Yeah. Well, the images that I showed you early in the presentation, those actually, because it's so thick, they actually held their form pretty well.
Okay.
But I mean, there's no real practical application I can think of for doing that. It's just a test material.
So you take it out of the tube and put it into another
Yeah, we take
container
it from
to
one
extrude it?
tube, put it in another syringe.
Sure.
Yeah. Yeah.
Rose? So I'm curious, when you have syringes, how many syringes are you going through as you're building stuff? Are you using those, or are those like a consumable?
Right now they're consumable. We're definitely limited to the capacity of each syringe as well. So I think later in this project, and what's great is everyone who's owning the printer now can continue to update with us.
Right.
But we'd like to have an external, maybe like a bladder for the material to be pushed through, so you could fill up as much as you wanted and send it through a cable. Yeah, right now they're disposable or consumable. Yeah.
And are you precious metal clay at all?
Pardon me?
Have you tried printing with precious metal clay?
Precious metal clay, no. But
It's
we've done some
a clay that has like metal, gold or silver in it, and
Oh, really?
you make jewelry.
Yeah.
The plastic is burned off.
That would be great.
I love it.
So one of the things that I think is really interesting about this project is, and when we think about 3D Maryland's mission of driving innovative economic development, is to take entrepreneurial, creative thinkers who are interested in the digital fabrication space and have them start to play around with this. Coming from a design background myself, I can tell you that if I had a vision of something to make through this technology, and the liquid nails, for instance, wasn't holding up, I would figure out what I could add to that liquid nails to make it hold up. And that's really the value of the creative in all of this, is that creative thinking, not, oh, it doesn't hold up, therefore I'm not going to use it and that's a dead end. The creative brain, and when it's really not for, it's for proof of concept, if you will, or for exploration, can I do it? That's where you get this innovation, and that's really part of our mission here, the innovative and entrepreneurial aspect of this. So I think it's really exciting. 3D Systems said that they were going to give 3D Maryland a chef jet, and I can't tell, it was really surprising to me how excited Stanley Black & Decker was about the fact that we might have a chef jet in the lab. So I'm really looking forward to having this and kind of supporting that ecosystem of creativity and exploration as we develop this technology. So we're really working all ends of the spectrum. And I hope that somebody can correct me. I know of 3 3D printers that are now being designed and made by Marylanders. So the Micro 3D, who someday you will see here on this stage, They're in production right now. The Jimmy Beta 3D printer, and Elite ImageWorks is a new SLA technology. That's, Carl, is it Hagerstown?
That's where they started. They actually just moved into the Frederick incubator.
Okay. Oh, great, awesome. So hopefully we can have them here or something as well. All right, thanks, Evan.
Thank you.
Okay, so halftime, I want to take a few minutes for some shout outs. I'd like to invite Steve Simonetti from Trimec to say a few things about Trimec Solutions.
Thank you, Jen. Good morning. My name is Steve Simonetti. I'm a Territory Sales Manager for Trimec Solutions here in Maryland, as well as Northern Virginia and Delaware. Jan touched on our company a little bit when she spoke at the beginning. We're an engineering resource company. Been in business about 18 years. We started out as a SolidWorks 3D CAD tool provider, and we provide a full suite of SolidWorks CAD design software. And from that spawned a recruiting and staffing wing of our business to help our clients find people to run those tools. And that followed with a partnership with Stratasys. So we've been a Stratasys reseller for 9 years in the Mid-Atlantic. We currently have 6 offices and getting ready to spawn a 7th up in Philadelphia. We're deeply rooted in the commercial and government DoD space with 3D printers. And my job is to meet with engineering managers, directors, owners, designers, drafters, and helping them figure out which tool is going to be best for their application, and there are many. So what's great for me in 3D Maryland, I was really excited about it. My experience in the field is that there's a great disparity between the small fraction of companies that use 3D printers now and the large group of companies that are trying to figure out whether it's the right fit, whether it's going to work for them, and which tool to start with. So I see 3D Maryland as a blessing for everybody that's in design in the state of Maryland to come and have a place to ask questions, meet end users, because those are the ones that are going to give you the straight skinny on every technology, whichever they use, and there is no magic bullet with any of these printers. So whether you have need to start learning about the printers themselves, or you need ready access to a resource that can help you with a project today, 3D Maryland could be there for you. They are technology neutral, which is good for everyone because they're not going to point you to anybody in particular on purpose, but we need to understand what your application is. So when you're trying to figure out where you start, it's a simple set of 4 questions that you need to ask. You know, what are your applications? What do you need to build your parts from? And what do those parts need to do from a performance standpoint? And when you take those 3 things, now you go looking for the technology that meets those applications. So Trimec would like to offer our assistance to help you figure that out. Stratasys deals with FDM, which is one of the older technologies on the market, as well as PolyJet from Object. So we can tackle maybe 90% of our clients' applications from those 2 particular technologies. And we thank you very much, and we're proud to be here as sponsor today for 3D Maryland.
Thanks, Steve. I think I mentioned earlier, Trimec has been a long-time partner with Stratasys, so they have a lot of time in the field. Okay, so as I mentioned earlier, I just want to make people aware that tomorrow is the first ever White House Maker Fair. So it's the White House, part of the White House's ongoing efforts to emphasize innovation, entrepreneurship, making, and manufacturing in America. So if you're interested in that, you can check out the whitehouse.gov website, /Maker Faire, and learn more of what's going on. They really are asking communities and cities to really galvanize and energize around these technologies and make the maker movement as a way of spurring manufacturing in America again. So I think it's a noble effort, and if you're interested in that, check that out. 3D Maryland has a few upcoming events. This Thursday, the 19th, from 5:30 to 9 o'clock, at the Maryland Center for Entrepreneurship, we will be hosting the Baltimore, Washington SolidWorks User Group. That event is free. We do ask that you sign up. There's 2 ways you can sign up. The one that we prefer is that you go to our Eventbrite page and sign up there. But we do right now we're working out the kinks of that relationship. So that's an existing user group. So there's 2 sites that people are registering on. Right now we have about 35 folks registered. So if you're looking for a community of of CAD users and SolidWorks users that you can really learn from. Please check that out. We have the bios up of the presenters for Thursday night, and they're very high level within SolidWorks. So that's there for you as well. We've had a phenomenal response 3D Maryland has to all of our activities and initiatives. And we have an innovation and prototyping lab, as Steve mentioned, at the Maryland Center for Entrepreneurship. We had to cap our open house and ribbon cutting at 300 people. You can blame Catherine Bedoya. She's in the back in a cute shirt. She made me cap it at 300. But there's been so much interest in that we've decided to have monthly informal drop-ins. So if you're interested in coming by and seeing what the Innovation Prototyping Lab is all about, we invite you to come by on July 9th. It's from 12 to 1:30. So the second Wednesday of every month, we will have an informal open house, a time where you can drop by. We want to be open and inviting. There's so much interest in the technology and seeing it working and what we're doing that we can't accommodate all your requests. Otherwise, we'd be giving tours all day long and not getting our programming out and getting other things out. But we welcome you to stop by. So the next one is July 9th, 12 to 1:30 at the Maryland Center for Entrepreneurship. You have a couple things in front of you. Obviously, this is some events coming up and also the speakers today. Please know that that's there. You may take that. If you sat in the back, you didn't get one. They're in the front seats. I was trying to encourage you to sit up front. I'm so nice. I don't get it. And then we also have an post-event evaluation on your chairs. We'd love your feedback. So 3D Maryland is really here. We're trying to identify needs, fill gaps in order to grow the ecosystem. We have a user survey up on the website, like I said, so we are really seeking your input. Who do you want to hear from? Do you want to speak? What do we do right today? Do you want more networking? How's the ratio? What else do you need? So we're really here listening to the broader community. What can we do to help you engage this technology and move forward? So please let us know about that. 3D Maryland is part of the Maryland Center for Entrepreneurship. I said that a few times. We have a lot of programs within the Maryland Center for Entrepreneurship, but another one that I would highlight for you today is this evening at Union Jacks in Columbia. We have the Howard Tech Council's monthly networking event, and that starts at 5 o'clock, from 5 to 9, and that's really a phenomenal event. Where's Chester? I met Chester there maybe 3 or 4 months ago. They're really phenomenal events. You can ask him more about that. And Tracy Turner is the program director for the Maryland Center for Entrepreneurship. She'll raise her hand. You can ask any of the folks in the back about those events as well. Okay, so does anyone else have announcements, events that are coming up, things that you're looking for, anything else you want to ask the group right now or share with the group?
See a show of hands of how many companies are here that currently use 3D printers in some form or fashion?
Good question.
Thank you. Again, a smaller group than the whole. So.
Other questions? Announcements?
Actually, I have a question. Is anybody who does not have a 3D printer, doesn't use it, why are they here?
Okay, so I know who didn't raise their hand, so I'm looking at you.
To find out what it would be, what you'd have to do to get into using a 3D printer, how much would it cost, what do you need to learn, those types of questions. Because it's fascinating, but you do have to know what you're getting into.
Hi, I'm Erica Gisones with the Cecil County Public Library. We're the northeastern Lewis County in Maryland, so if you've driven 95 to Delaware, you've driven right through us. We don't currently own any 3D printers in our public library branches, but libraries throughout Maryland are very, very interested in 3D printing because we do a lot of work with entrepreneurs and small business owners, helping them to find out how to get prototypes made or how these technologies can really benefit them. So we're interested in learning what would be the best product for us to get that our staff could maintain and that would help our patrons in a wide variety of ways.
And so again, I really want to emphasize the networking part of this event because there's a lot of knowledge in the room and there's a lot of opinions. And so even what I was doing earlier this morning was I know people that have come with questions today, so I'm really trying to connect them saying, here's an opinion. This person has an opinion about your question. Here's another person has an opinion about your question. So please, use that time. Yep, Sean?
Yes, one of the the public library having a 3D printer, I think it's a great idea. But one of the difficulties in getting kids educated is trying to get them to think of 3D. And I would think that, let the kids play. They really need to use those things, plus the digital skills that they get. I always go back to my sister, who was the artsy type in our family, who was very, very happy she'd never have to take another math class. Again, this was back in the 70s.
Yeah.
Well, art went digital around 1978, 1979. Within 3 years, she had the most powerful computers of anybody in the family, and she was all doing graphic arts work. There is so much that, there's a lot of creativity in the kids. Learning to think in 3D is probably the key step in getting people into engineering and into a lot of the sciences. So it's a powerful tool. So don't just think about the entrepreneurs, think about
Sure, and we wholeheartedly
regular
agree.
customers.
We did our first big 3D printing workshop recently, and it was aimed at middle schoolers. It was completely full. It was awesome, and they were there for like 4 hours.
Completely glued, yeah.
Yeah, and they made like their own thing. We printed it for them in the subsequent weeks. The biggest challenge for us is funding, because we don't really have lots of money lying around to purchase something like this unless we can prove or have good evidence that it's going to bring money back into our local economy through job creation, entrepreneurship.
Is it money
but
mostly
education, of course.
Is it mostly for materials and things like that, or is it to buy the printers?
And
or-
also staff time.
Staff time.
Well, the micro 3D printer, which was designed in Maryland, is being manufactured in Maryland soon. First run's coming through now. It's about $350. So I agree. So let's get that in every library and every school. Dick Story had a question.
I didn't raise my hand because I don't use 3D printing. Can't imagine how in banking that we can replicate money.
As soon as you find out, I want to know.
I can tell you on my copier, it will stop at $20 bills.
We still love you.
I'm here because I'm a member, I'm a member of the Jan Baum fan club. As a banker, we're here to work as a community bank with Howard Bank. We're here to help the community grow and the business communities to grow in it, and we'll grow with you. So that's my commercial as a banker. My question to Jan is, as you move into a new building, what does that do for your program and the whole center?
I haven't even touched down from the last 7 months. We're not there yet. We will see how that goes. It's a year. That's a year. The Maryland Center for Entrepreneurship and the Howard County Economic Development are moving into a new building in Columbia, the Columbia Flyer Building, and so we're not even beginning that planning phase quite yet. But it's a very big conversation. So it depends where the initiative is at that point and how we can continue to serve. I will share with all of you, and I would love for this to continue. These waters are very dynamic. Every single day, every week, something different shifts and something happens. And what I love about the community that we're building, or I should say that we're facilitating, that we're like being the conduit to bring together, is the emails that I get from you folks in between and after meetings. And so recently someone said, hey, we want to beta test something in your lab. It's maybe something that we didn't think about, or we didn't know that was a need that needed to be filled. But if we're here to drive innovative economic development, spur 21st century jobs in Maryland, and make that one of our marks. So that actually fits into our mission. So then it becomes, how can we, right? And so that's what's so important, as Dick is saying, about the community and linking arms and figuring out how we can do this together. I do believe that this industry is in a pre-competitive collaborative stage. And I think we are going to do the best in Maryland if we act as if, and we work together at this point in moving forward. Maryland has resources unlike many, many other states. Whether it's our federal labs, see, now you're getting a little soap off, and I just killed my own schedule. I was so on. I was ahead. We have so many resources, and whether that's the federal labs or the expertise and the assets that come with that, which we want to support and we want to keep them here. Whether it is the university system, and I think what Evan has done at Maryland Institute College of Art is no small potatoes. Knowing that Micro 3D is out there, and they are like one of the benchmarks for Kickstarter campaigns. They blew their Kickstarter campaign off the charts, and I don't have the stats at the top of my head, but I can talk about it at MEDA this year. We have so much to work with, and we have so much entrepreneurialism, we have so much innovation, and bringing that together, I think Maryland has a huge chance to make this our mark. And honestly, I've been down to DC a number of times, and they're looking at us going, no one else is doing kind of what you're doing. And even America Makes, which is the federal initiative, they said, you know, Jan, you need to be part of our road mapping because you're organizing the state, and that's what we need to know, and we need to be close to an agile system. And so I think we have a lot of opportunity, but we have to work together. So I'm so glad, again, like that TriMech is here, that you guys are all here. There's a huge diversity in this room, and it makes me so happy. Let's double it for August, can we? All right, last question. We're going to go to the next presenter, Bob Goodsit.
Yeah, hi, how are you? I saw an announcement the other day that the Canon Copier Company will be selling 3D printers. And I just wanted to mention that when and if this happens, when your secretary goes into the shop to buy a nice office copier printer, she might come back with a 3D printer. That's a smile and a half for those of us who've been in this business for a while.
Thanks, Bob. All right, next up is Eric Guzman. Eric is a lab and program manager at 3D Maryland. He pioneered one of the first digital fabrication labs in New York City, building a comprehensive lab integrating both traditional and digital technologies, including high-end 3D modeling software, 3D printing, and digital scanning. And Eric is a software expert. He is very self-effacing and very modest. His knowledge of software is incredible. And he's going to talk about what I think is a forward-looking software program called Modo. When I was first introduced to Modo maybe a year or so ago when I hosted an event called Betascape, we had another expert do a demo on this software, and I just think it's leading edge software. So please welcome Eric Guzman.
So just to kind of talk about a little bit, intro what Sean was talking about making people really understand what 3D software is or thinking in 3D. This presentation is pretty much for the software packages. The machines are fleshed out. We all know that they always work all the time, perfect, phenomenal. But I think the biggest thing that people get very excited, but then they're like, well, I want to create now. How do I create, and so forth. And it's a complicated answer because it's like, okay, well, there's animation packages and companies have been making things for Pixar and Disney for a long time. On the other hand, you have solid modelers for manufacturing. So you have kind of two realms that sometimes play with each other and sometimes don't, and so forth. So this is kind of my work through that I've worked with. It doesn't mean that I back up this software company or whatever. There's other companies out there, software packages that work equal as well. Everything in 3D Maryland, we're trying to look at everything, all software packages, all machines, and all that kind of work. So very quickly, this is just a very simple explanation. I kind of started with SolidWorks because it's something that's parametric. I can trust it. I understand when I download something, it's solid. The measurements are proper. Modo is a sub-D modeler, which means more organic modeling or organic shapes and so forth. So they kind of get paired together. Mesh Fusion is a plugin for Modo, and when it comes to Boolean, putting two objects together, subtracting them, and so forth, in a sub-D modeling world, it's always been very chaotic, and they always say it works, but it never works at all. So Mesh Fusion is the true. It works really well, and so forth and so on. And then recently, MakerBot and Modo have paired up to say, we're partnering together each other. So obviously, MakerBot is trying to find out some kind of sub-D or soft modeler because the CAD, the solid modelers are already understood. SolidWorks or other, parametric modelers and so forth. So this is just a kind of something I whipped up. I wanted to design a speaker with two different elements, small speaker case, something that was organic, elephant head, and then basically the case itself where speakers fit into it, and so forth. The nice thing about Modo, as you can tell, it has a decent renderer. The renderer, which I'll explain a little bit later in detail, is the same render Luxology makes it, which is in SolidWorks too. So when you go to SolidWorks and kick out your render, it's pretty much the same company working together. Nice thing about this is that, download speakers from online. A lot of places have step files that you can download, and then you know that all the files are right, and then I can engineer whatever I want around that and so forth. So, mid-range, tweeter, I know that that's right, and then very simple SolidWorks, main body here. But to make, so after I make it in SolidWorks, the nice thing about it is that Modo does read SolidWorks files, so you can sit there and open up a SolidWorks file in Modo, and then you have a lot more visualization that you can kind of get your hands on. You can put cameras, you can put lights, you can kind of like move the objects around. You can also animate objects and so forth. You can do that in SolidWorks too, just a little bit of a different animal. But anyway, there is a little bit of cleanup, but all software packages say that they do everything perfect. You always spend a little bit of time fixing something up, So anyway, it's just the modeling tools are intuitive, easy to use, and with very few hidden menus. A lot of people do not like sub-D modeling because it gets very deep and there's a lot of menus and you have to go search for things and so forth. Modo is very on the surface. What you see is what you get, which is quite nice. Logical workflows. This workflow is more for animation, but it's still for also designing, design elements. First of all, you model it, then you're going to sit there and paint it or put texture on it. Retopologize, to retopo means it makes the mesh cleaner. UV is basically anything that you paint has to have a UV on it so you understand where the color goes to. Like the 660, we have the ProJet 660 at 3D Maryland. A lot of people ask about well, it has color. How can I use color? This is really great. Well, SolidWorks lets you assign color to your solid parts. But then again, when you go to sub-D modelers, you have to make a clean UV which wraps around your object, and then that's how you translate your color to your geometry. So I said this before, renders the same as SolidWorks rendering, and this is kind of a very simple pipeline for figuring out how to model something organically. I just use the elephant because it's got lots of shapes to it. This could be a very simple hinge or a cabinet and so forth. But basically, you start with a pictorial source, the same thing in SolidWorks. Do a simple primitive, and then you get a little bit more complicated into what you want to get to. The nice thing about it is that it allows for visualization with your clients. Sometimes if your print is going to be expensive to kick out, one thing that you don't want is your client to come back and be like, that's not what I wanted. It's like, well, so this allows a little bit with that understanding. It might take a little bit more time with the software package, but if your 3D print is, I don't know, $2,000 to print out, and it's a big job, then this is a nice way of kind of dealing with that client interface through iterations of it. The nice thing about it is now is that also from Modo you can kick out STL. So for the program itself, I think it's around $1,400. So it's one of the lower price packages, and it kicks it out to a 3D printer and so forth. So if you're looking for a sub-D modeler, that works pretty good. The community is great online. You post something within 24 hours, you get lots of responses. There's also a huge database of people making mistakes all the time on the forum. So they're like, oh, I made a mistake. This is really how you do it, so forth and so on. And then I just wanted to show you for the visualization thing. This is just very simple, but I just started and I just animated it. Oh, it's spinning a little bit too fast, and it's no color. And then, oh, maybe I want it to be orange, and it rotates a little bit less. So once you've done the initial work, you can sit there and spit out a lot of visuals to kind of go through your, to bring to your client and say, oh, okay, well, and then also maybe I wanted to sit there and have all the parts come together and make it look all matrix-wise. Like, oh, it's going crazy, it's spinning, there's different colors, it's awesome. So there is definitely the show and tell kind of thing. And then finally, maybe I just want to have it nice and simple, all black and white, where everything kind of comes together and does that. So the visualization is very, very good for that. So when it comes right down to, I just want to touch base in Mesh Fusion. I know that we're kind of short on time. But what it does is it allows you to bring 2 or 3 or 4 different mesh bodies together and lets you add them or subtract them on the fly. And if you change one of the objects, the master will change automatically, which is super. If anyone's done modeling, that's like heaven sent. If this is your starting point, you're super spoiled, because I think that this is like the starting point. Like all programs should work magically and everything should function. But anyway, it's a very, very strong thing. Braid Art Labs developed this technology, I believe 2 or 3 years ago, but then Moto got bought by a huge company called The Foundry, which does a lot of post-production animation software and all that. And then they bought, they brought them on board with Mesh Fusion and so forth. So just a kind of little bit of screenshots. The nice thing about it is that you have 2 bodies and a 3rd body, and then these 2 bodies get subtracted from that. But you can visually, so this subtracts there, and it gives you a nice visual schematic next to your model, so you can see what you're doing when it's doing it. And this is a combine, and then this is an overlap, and these are just 2 websites for MakerBot going to Mesh Fusion. So that's pretty much just the software section of it. I didn't want to blow through it too quickly, but this is a short demo and so forth, and there was a lot of material here. I just find that like the different things for people to understand how to get into the software is kind of important. You see all the stuff online, everything looks great, but then when you download it and try to print it, sometimes it doesn't print, and so forth. So these are kind of 2 program things that I kind of found that work good for me.
All right, thanks, Eric. Questions?
In the mesh model, you can do booleans, and you can do that for something like Magics. Magics can't do a radius on a part after you've done a boolean operation.
Yeah.
Can you basically apply radiuses to your mesh parts easily using Moto?
It has an edge. What it does is that for the radius, what they do is it's an edge loop, and then you change that percentage on that edge loop. So you'll have a hole that goes over into a surface, and then you can click on that edge, and it has a little slider that sits there, and you can have a really sharp edge, or you can sit there and have a filleted edge and so forth. It's better. There's another plugin that goes back into SolidWorks that lets you then have all the power of SolidWorks. So you'll have a sub-D OBJ model that goes back. So you can do a lot of organic models in Moto. I am okay with surface modeling in SolidWorks, but no matter what, there's there's levels of SolidWorks users, and most of the time if you're a surface modeler, your prized position, you're like really expert. So so SolidWorks lets you do these things, but there's no way you could do like an elephant head or a super organic shape and so forth. But so you can do this in sub-D, but you don't have the parametrical capacity to dial in things in a sub-D modeler, where in SolidWorks you have this nice safety feature where you're like, oh, I want this to be 10 inches or 5 inches or centimeters and so forth. So that's why I kind of go back between the two software packages.
What's that plugin called?
Mesh Fusion.
That is a Mesh Fusion.
Yeah. So that's why I did that. Huh? Yes.
Could you give us your contact information?
Jan?
E. Guzman, G-U-Z-M-A-N.
Sorry, say that again.
E. Guzman, E-G-U-Z-M-A-N, at hceda.org.
I'm sorry, at the beginning I'm the lab manager at 3D Maryland, Eric Guzman.
E. Guzman at...
We'll get you after. Other questions? Other questions for Eric?
Yes.
Everyone seems to be using Macs. Is that because the SolidWorks is better in that?
No, it's an illusion, actually. No, it's a little bit of a problematic thing. A lot of the software, when you get to a certain level, is PC. At the base level, a Mac is easy, it's fine, there's nothing wrong with it. Autodesk has a lot of software out there for you to use and so forth. When you make that decision to spend, $2,000 to $3,000 on a printer, and then you make the decision to sit there and get a, whatever more expensive printer, then you're gonna be like, oh, okay, I think unfortunately, I need to get a PC and then work on that platform. So it's still, SolidWorks is a Windows-only platform. So.
All right, you'll have I'll have more time to ask Eric questions. Rose, don't lose your question. Okay. I'm going to try to make up here a little bit of time, give you a little more networking at the end. Our last presenter is Blake Voschel. Blake is an expert in 3D modeling, earning numerous awards in both civilian and DoD work. He founded Avid Imagination in 2013, a company specializing in model making for architecture and trade show exhibit industry, as well as concept prototyping and finished components. So please welcome Blake Voschel.
So I hate class participation, so class participation time. Who is here kind of doesn't know anything about 3D printing? Few. Who here is actually looking to purchase 3D printers? So you want knowledge about kind of what the differences between them, or you kind of know where you're going? Okay.
Blank slate.
Probably yes.
This will be a little diverse from the original then, since most of you either A, have a printer or know how to use one. Started off actually in 2005. It was the first time I heard about 3D printing. It was through Forensic Engineering Resources. I was doing a brochure for them, and they were using Z Corporation. Z Corporation has been around for a long time. 86 was all. They've been around for quite some time. They've been mostly powder resin, so that was the first initiation I had into 3D printing. About 6 years later, never knew it wrap back around because I do design, and we work with wood, plastic, acrylic, stuff like that. Went from working with that to creating 3D models. Worked for the Army full-time, DoD. We were asked to create basically a sand table model. The initial concept was to create it from wood. We had model makers that worked there full-time. There's 3 of us, there's 2 of us now. And that's what they used to do for a living. Since 1960, the one guy's actually 76. He's been working for the same company, same building, same office for 43 years. So with that, I decided to bring us a little bit of new technology. And for something like this that we created, the scale is 1 to 153. So to do that in wood is near impossible. So we started looking at 3D printing. We actually only had a limit with the government of $25,000 for any purchases. So we took a look at 3D, took a look at powder resin as more of a way to do details without having support material that you have to break the snap off. So for 3D printing, as in powder resin, it's a lot better for us at a lower cost than to use something like any photopolymer. Stuff like that is way more expensive than what we could afford at the time. Let me give you the bed sizes real quick and the layers, and I wrote this down because I knew I was going to forget there's a lot of decimals. For a powder bed with a binder jet, we have the Z150, which is actually now not the Z150. It was bought over, I think it's a 160 now Pro Jet. The build bed is 9.3 by 7.3 by 5. Layer thickness is 0.004 inches. For material jetting, such as the Outjet, it's 11.57 by 7.55 by 5.85, and 16 microns for thickness. So you get a lot better detail and higher resolution when you go with the material jet-wise. For the material extrusion, like the FDM printers, it's a 10 by 10 by 12 bed for dimension SST, which is comparable to the Z150 and the Outjet 30. But the detail and resolution, as you saw when that was passed around, is a lot less. So to create models that are finished like this, we decided to go with something that you didn't have to have support material, and you could also really easily not have to there's a lot of work involved in it for the after process, but the before process is simple. You don't have to add anything to it. You just stick your model in and it prints. It's an inkjet cartridge. It's actually an HP inkjet cartridge. It takes all the ink out of it and replaces it with a binder. It's basically a sugar solution that binds it together. Some people have actually used vodka, I've heard of, but that's hard for the Army to buy. I tried, it didn't work that well. They say it creates a stronger strength, but boys and warrants and all machines it, but I have no idea why. So when I started my company, I have an imagination. I kind of took it to the step where I didn't want to do the after processing. It's an archaeological dig after it prints out. You have to vacuum up all the powder, which is nice because you can reuse it. However, all small parts in it, you have to be extremely careful about moving all the powder around them. Once that's done, you have to take it out, doing an infiltration with cyanacrylate, which is basically modeling glue. Which if you use that a lot, you get an upper respiratory infection and go on medication for about 2 months to breathe again. Besides that, after we got the hood, everything was fine. Yeah, that was fun. So look on my own, actually purchased the machine off Steve Simonetti in Trimec. So if you need parts printed, see me. If you need a machine, see Steve. Shameless plug. So this is the machine I have, it's Object 30. I picked it just because of the resolution. There's not a lot of things you have to do after. This is basically what it is. This is how it came out of the printer. I didn't do anything to it, no sanding, nothing afterwards. And it's about 5.5 inches by 4.32 and a little less than 3 inches tall. It did take 15 hours, but for the resolution and not having to do any post-production wise afterward, it's completely worth purchasing. Now, if you want to go in a stronger material, you have to go for the FDM. The object's more like Tom Brady. It looks pretty, but doesn't like it. The FDM has a lot stronger tensile strength, and it's a lot more durable than this material. Even heat-wise, a lot of rapid prototyping uses FDM a lot. I work with Alio Designs with Guru Remove, and he has 2 FDM printers, and he also has an Object. So to kind of like sum up everything, depending on what you're doing, you're going to have to pick the printer. I know this is a really quick layover of exactly what each type of printer does and what the resolution is, which is what I was most interested in when I was picking a printer. So I apologize for that. Yeah, you can go on Wiki. They have a lot of sites for 3D printing, a lot of information that I can go right now. But if you're going for strength, you got to do FDM. If you're going for detail, you have to do the poly, like an Object. And if you're going for quick and easy and like archaeological digs, go for a powder resin. Yeah, they're actually using powder resins in a lot of foundries, and we Voljet created a huge, like room-size powder printer that BMW and Ford are currently using to create some of their parts for mass production.
Voxeljet.
Voxeljet.
All right, thanks, Mike. Got to be questions because he threw a lot of information out that I know not everyone understood.
It only took you 2 months to get over your upper respiratory infection.
Yeah, just 2 months. It wasn't too bad.
Get medication.
Yeah, I was around 3. Not a pleasant experience.
No.
Cliff, how do you suggest learning which printer you need or which printer is better?
It really depends on what you're using it for. Once you establish what you're using it for, then you kind of dissect which printer is going to do that. Like I said, if you're going more towards the strength, it's FDM. If you're going more towards the full-time prototyping, it's FDM. Rapid prototyping is going to be your Object for quick detail work, and powder bed is more for like the big foundries and things like that. We just got one because that's what we go for at the time.
Okay.
And Cliff, I would add, get to know the community of users, because you'll gain a lot of data points there. And then you're talking, like, you can gauge your source and you can understand how they're using it, and there's a lot of information and value in that. So there's a lot online, but you don't necessarily know how reliable those sources are.
That's why I asked the question.
But in a community of users, you can sort that out. There's a question over here, Sean.
Yeah, one of the things we have to worry about with printed parts is them being watertight, which is an issue with the definition monument parts. And then with the 3D printed parts out of the object, there's all the support gel on the surfaces. How do you remove that completely? But we found it to be extraordinarily difficult. And then the last question is, does an object have a colored 3D printer as well that converts your white parts into, basically make a colored part also?
Yeah, I'll answer backwards. Object does have a colored 3D printer. They just came out with one that actually blends colors together. I think that's through the Envision. Is that correct, Steve?
Connex.
Connex.
And it's a Connex 3. It blends 3 materials at once.
The second, going back, you're from Repliform, right?
Yeah.
I guess kind of do it the same way that you do it to remove all the gel. Put in a solution, liquid Drano, or crystal drainer rather, 5% or 10% depending on how thick the part is to water, and then just a water jet. A lot of hand sanding afterwards. If you use the gloss, I don't sand the gloss afterwards. I just put a coat of primer over top of it, and that's it. But for your processes, that's not going to work that well.
Well, the gloss works fine. It's the
Oh, does it?
It's the underhand that we have a problem with.
Okay. Yeah, I just hand sand it down to 600 sandpaper after I get as much as I can off with either the solution or just a straight water bath.
Other questions? Bob?
What was the name of your company, sir?
It's Avid Imagination.
I'm sorry?
Avid Imagination.
Thank you.
Questions? All right, as promised, well, I promised you 30 minutes, but I'm giving you 20 minutes of networking. Thank you, everyone, for coming. Thank you, all the presenters. Again, remember, we'd love your feedback on the evaluation form. You can also tell me directly if you want to hear more, want something different. This is our first one. We are a work in progress. So thank you all for coming. Thank you for making today a great success, and we'll see you soon.
Thank you. We've had people, do well. We've tested here, but no pressure. But I will, who's your typical client?
specialized design help, but yeah, I've done some work
yeah, the 666 approach that they acquired. So it's completely different.
yeah, the other thing is someone